Let's talk about how to optimize the memory efficiency and the attribute lookup time of our Python classes. We have a class here called point in a points module, and here's an instance of this class. Normally, class instances store their attributes in a dictionary called dunderdict. For our class, every instance has x, y, and z attributes, but we could add other attributes to any instance of this point class, and another key value pair will appear in our dunderdict dictionary. This is how classes work by default, unless you use dunder slots. To use dunder slots, we need to define a dunder slots attribute on our class that points to a tuple of strings that represent valid attribute names for each instance of this class. If we make a new instance of this point class, we'll see that it has an x attribute just as before. And we can change the value of this attribute just as before. But if we try to make a new attribute that is an attribute that isn't x, y, or z, we'll get an attribute error. We get an attribute error because each instance of this class no longer has a dunderdict dictionary where it stores its attributes. Instead, dunder slots uses something kind of like a fixed width list to store these attributes. So because we're using dunder slots, we can't expand the number of attributes that are on each instance of this class. Classes that use dunder slots use something kind of like a fixed width list to store their attributes, so we can't expand the number of attributes on an instance of a class that uses dunder slots. Why would you ever use dunder slots in your class? You could use dunder slots to restrict which attributes are allowed on instances of your class, but that's not the most typical use of dunder slots. Typically, it's used to save memory or save time. Instances of classes that use dunder slots store their attributes in a data structure that's more memory efficient than a dictionary. Also, attribute accesses on those class instances should be a little bit faster because they avoid a dictionary key lookup, which requires a small computation. Note that in our points module, we have a point path from file function. We're going to write a command line program, pointstats.py, that will call our point path from file function. This point path from file function makes a new point object out of each line in a given file. And our command line script averages the x, y, and z values of all those point objects and then prints out the mean of those values. If we wanted to see how much memory our program takes up, we could use Python's resource module to print out the maximum memory usage of our Python process. This strategy for printing out memory usage is a bit fuzzy and it doesn't always work exactly right, but it's a pretty decent start. Running our program again tells us that we're using 174,000 bytes. Now remember that currently our point class uses dunder slots, so it should have slightly optimized memory here. But what if we modify our points module to remove the dunder slots attribute from our point class? If we run our code again, we'll see that it takes up more memory this time because it needs to store a dunderdict dictionary for every instance of our point class. Without dunder slots, our program takes up over 200 kilobytes, a bit more than the 174 kilobytes that it took up before. If you want to make instances of your class more memory efficient and faster for attribute lookups, you might consider using dunder slots. But keep in mind that this only makes sense if you're making thousands of instances of your class or your code has a lot of attribute lookups.